Sketch the curve. I look very tired. Sketch the curve. Sketch the curve. Y is equal to x cube. Sketch the curve. Y is equal to s cube. Sketch the curve. Y is equal to s cube minus 3x squared. Y is equal to s cube minus 3x squared plus 3x minus 2. Have you gotten it? Sketch the curve. Y is equal to sketch the curve. Y is equal to sketch the curve. Y is equal to x cube minus 3x squared. X cube minus 3x squared plus 3x minus 2 plus 3x minus 2. Indicating all the turning points and intercepts. Indicating all the turning points and intercepts. Have you gotten the question, please?
Yes, sir.
Okay, so let's do it. Let's do it together. This thing is misbehaving, but I'll try. So we are given y is equal to s cube, right? S cube minus 3x squared. Minus 3x squared plus 3x minus 2. And the question says we should find all the turning points and intercepts. So why? Let's say you have repeated it. So we first find for the first turning point will be dy dx, right? Dy dx.
Yes, sir.
When we do dy dx, what are we getting? I'm getting 3x. 3x squared minus 6x plus 3. Plus 3. Please, are we seeing it? Then we equate, if the turning point is 0, we equate it so that we can be able to get to the points, the turning point. So 0 is equal to 3x. Please use a calculator to do it. Let me see.
X is equal to 1.
X is equal to 1. So x is equal to, is it only one? Is it only just a value? X is equal to 1. So
Yes, sir.
let's get its corresponding y value, just as we've been doing it. So let's put it in a y and get its corresponding y value. What is y? What did you get?
Minus 1.
So minus 1. So our turning points are into brackets 1 minus 1. Okay, now from there we come and find for it says we should find for all indicating all turning points and intercepts. So what we are first going to do, we are going to do second differential. I hope we agree.
Yes, sir.
The square, that is the x squared, is equal to, so let's differentiate it again and see what we get. You get 6x minus 6. So you get x to be x will be equal to 0. Do you agree? Or 1?
Sir, 1.
So x is equal to 1. But before that, when we are doing this thing, what do you call it? We put the x value in this one to see if we can get what do you call it? If you can get whether it is whether the point we had, the first point we had are what are their points of inflection, their maximum values or minimum values. So
Okay.
if x is equal to 1, after the second differential, we substitute x into it. What are you going to
Say
get?
zero.
It's 0.
Zero.
So
Yes.
0. So that means we can conclude that the points are points of.
Inflection.
Yes. So the points are. And so the 1, -1 are points of inflection. So 1, -1. Sorry. 1, -1. Are points of inflection. The points of inflection. The points of inflection. Now, then the question is we should find for all the turning points and the intercepts. So when we are finding for the intercept, what do we do? When we are finding for intercept, what do we do? For the x-axis, for the intercept on the x-axis, we put y is equal to 0.
Y is 0.
And so when y is equal to 0, when y is equal to 0, when y is equal to 0, what are you going to get? You are supposed to get some a lot of numbers. When y is equal to 0, what will we get? Use your calculators to give me the values. So that will be 0 is equal to the whole of the first one, because we are putting 1 to 0. So 0 is equal to this. 0 is equal to this. When we find the y-intercept, y is equal to 0. So y is equal to the whole of this. And what are we getting? Please put it, use your calculators and let's see. Please, what did you get? Oh, won't anyone mind me? Those were the calculators. When y is equal to 0, what are you going to get? When y is equal to 0, what are you going to get? That will be 0 is equal to s cube. 0 will be equal to s cube. S cube. Or your calculator is not giving the answer. Minus 3x. 3x squared plus 3x minus 2. What are you getting? X is equal to. X is equal to.
1x was 2.
1x
And the
was
rest
2. And the rest was what?
Yes.
And the rest was.
Half plus root 3 all over 2i.
So we can even pick only the 2. And so that means our first we have another coordinate 0, 2 and negative 2 and 0. Do you agree with me? Y is 0 here, and when we put it into it, you equate it, you are going to get 2. So when y is 0, x is equal to 2, and 0, what do you call it, half 0, and the other one. But let's just keep the 2 and the 0. Then we come and do the y-intercept. With the y-intercept, x is equal to 0, right? Intercept. The intercept x is equal to 0. So do it for me.
Yes.
Let's see.
So y is equal to -2.
So y will be equal to -2. So sorry, -2. So the other points to be at the y-intercept, the point to be 0 / -2. Are we true? So we have this point, we have this point, we have this point, turning point, we have this point, we have this point. Do you agree? Oh, mind me.
Yes.
So from this point, we can draw our curve. So you can just have our curve like this. You can have it like this. Then let's say you can have 1, 2, 3, 4, 4. Then maybe you can have this on -1, -2, -3. You can leave it like that. Then we can have 1, 2, 3, 4. So what will be the first? The first one is 1 minus 1, eh? So this is the first one. Then the second one is 2, 0. What is 2, 0? 2, 0. So this is 2, 0. Oh, I'm wrong. This is 2, 0. 0, 2. So we can have 1, 2 here. Then we have 0, -2. 0, -2. Why is it 0, -2? So why is the 0, -2? Y is y is 0, and we have -2 here. So if the points are many, you can just plot them. When you finish, you just trace them. So this is like this. This will come and pass through this, and come and pass through this. So this will be your curve. Have you seen it?
Yes.
Oh, the rest, talk to me. Eh? Oh.
Yes, sir.
Oh, so this will be how the curve is. So I've taught you how to find the point of inflection. When it is point of inflection, I've taught you how to find when it is maximum or minimum. You know how to find it. Then the turning point, you know how to find it. Differentiating dy dx, then you equate it to 0. Then that is it. You come and put 1 into it and see the x into it to see whether it is a point of inflection or maximum or minimum value. You know all these things. I've taught you. Then from there, you come and find the intercept, especially when you're drawing the curve. You come and find the intercept. If it is x on the x-intercept or on the x-axis, x-intercept y is equal to 0. So you equate y to be equal to 0. That is why you are giving a question. Then you use your calculator to do it. Then you write the values. If you get 2 values, then that means it will be, if, for instance, if you had 2 x values, 1 and 2, when you equated y to be 0, that will now come and be, the first point will now can be 1, 0. Then if it is 2, 0, and when you finish, you come and let 0, y, what do you call it, on the y-intercept, you also make x be equal to 0. Then you come and equate that one too. Then you're good to go. Are we there?
Yes, sir.
So that is all. We have the last topic. Let's do it and go and sleep. We are going to do, are we done writing? Let's do kinematics. Let's do kinematics. I'll just use some few seconds to do it. It's very simple. I know you know kinematics is in physics. I hope you know kinematics is in physics. Yes. So under this, we are doing linear kinematics. And so when we are talking about linear kinematics, then we are talking about velocity, linear velocity. We are talking about linear displacement. We are talking about linear acceleration, or we are talking about acceleration. Now you bear with me that kinematics is the study of the position of a moving body and how it changes with time. And so the linear is related to the straight lines or something which have the properties of a straight line. So when we say linear kinematics, basically that is what it means. So we are talking about the study of motions in a straight line without the consideration of the nature of the forces which are acting on it or the laws of motion under this place. So here we are going to talk about displacement, we are going to talk about velocity, we are going to talk about acceleration. I think basically these are the two things we are going to do, but we are going to use differentiation to talk about all these things. We are going to use differentiation to talk about all these things. Then we are done for the day. Then we are done with the first part of differentiation. Next week we are starting integration. It's a new topic, so please try and be part. Can I please wipe the board?
Yes.
So
Yes, sir.
we first talk about displacement. We know that displacement itself is what? Displacement is distance covered by a moving object. The distance covered by a moving object in a specific direction. So the displacement can always be described as a function of time. So we can say that displacement, which is denoted by x, is equal to function of time. Function of time. So that is it. Now from there, we can also talk about velocity. And velocity is the of a moving particle is the time rate of change of displacement. So now we already know that velocity v can be given as ds dt. Do you agree to that?
Yes,
The ds dt means changing, the d means changing distance or displacement all over changing time. Then we can talk about acceleration. Acceleration is changing what? Changing velocity respect to time.
velocity.
Already of this we know. Now acceleration can also be the double differential of displacement. Do we agree? So acceleration can also be acceleration. We can also write acceleration as the square v divided by the t square. Do you agree with this one? Because let me explain if you don't agree. Because you realize that when you differentiate this one, you are going to get velocity. Now, when you differentiate velocity to, you are going to get acceleration. So that means when you differentiate this one twice, you are going to get acceleration. So this is s right, instead. Do you get it? So when I differentiate this one, I'm going to get this. When I come and differentiate this, then I'm going to get this. Then that means if I want to get a straight given this, I can differentiate. When I differentiate this one twice, I can also get acceleration. Please, are we there? Hello,
Yes,
are we there?
sir.
Okay. So basically that is it. Now we are going to talk about the distance. So let's do some examples and see how it works. A particle moves. A particle moves. I don't know why. Why is the water so cold?
Sir, please.
I can't hear you. Is the water so cold? I'm feeling very, very cold. So a particle moves in a straight line in such a way that a particle moves in a straight line in such a way that a particle moves in a straight line in such a way that a particle moves in a straight line in such a way that its distance s meters. A particle moves in a straight line in such a way that its distance s meters. A particle moves in a straight line in such a way that its distance s meters. A particle moves in a straight line in such a way that its distance s meters from a fixed point O after time t seconds is given by a particle moves in a straight line in such a way that its distance s meters from a fixed point O after time t seconds is given by s is equal to 2t cube, s is equal to 2t cube, s is equal to 2t cube, s is equal to 2t cube minus 9t squared minus 9t squared minus 9t squared is given by s is equal to 2t cube minus 9t squared plus 12t plus 3 plus 12t plus 3. Let me read it again. A particle moves in a straight line in such a way that its distance s meters from a fixed point O after time t seconds is given by s is equal to 2t cube minus 9t squared plus 12t plus 3. S is equal to 2t cube minus 9t squared plus 12t plus 3. Find A. Its velocity after 3 seconds. Find A, its velocity after 3 seconds. Find A, its velocity after 3 seconds. Find A, its velocity after 3 seconds. B, it's when and where the particle is momentarily at rest. When and where the particle is momentarily at rest. Where and where the particle is momentarily at rest. Are we there?
Yes, sir.
When and where the particle is momentarily at rest. Now see, its acceleration after 2 seconds. See, its acceleration after 2 seconds. 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 D, its velocity at the time when the acceleration is 8.4 meters per second. Its velocity at the time when the acceleration is 8.4 meters per second. So the first one is you have to find for its velocity after 3 seconds. So to find for velocity, what do we do? Given S, to find for velocity, what do we do, please?
Sir, please, the D. Please, can you read it again?
Its velocity at the time when acceleration is 8.4 meters per second square per second square. Its velocity at the time when acceleration is 8.4 meters per second square. So the first question is we should find for its velocity after 3 seconds. So find for velocity when you are given distance. What are you going to do? V will be equal to. Someone should talk to me here. He said that will be the S dt. So the S dt will give us the S dt is equal to, what are you getting, please? That will be 6 t squared. 6 t squared minus 18t, right?
18T.
18t.
Yes.
Plus 12. Plus 12. Now they said we should find the velocity after 3 seconds. So that means if t is equal to 3 seconds, what is the velocity? So v will be equal to. So if t is equal to 3 seconds, what is the velocity? So we factor the t into the equation. There's a velocity equation. So when we factor t is equal to 3 into it, what are you going to get? What are you getting, please?
12.
12. So the velocity after this thing is 12. 12 meters per second. So the velocity after 3 seconds is 12 meters per second. Do you agree?
Yes, sir.
So the B2 says when and where the particle is momentarily at rest. That means indirectly trying to say that when the particle comes to rest. When the particle comes to rest. Now, when the particle comes to rest, then that means velocity will now be equal to
0.
0. So that means when it comes to rest, velocity will be equal to 0. So v will be equal to 0. So we factor 0 will be equal to the equation, this equation, because there's velocity. What are you getting? When it's time. So when and where the particle is momentarily is at rest. So that means you're talking about the time. So let's do it. So when we equate the ds dt is equal to 0, what are you getting?
WC said.
Is that the question is that we should find when and where the particle comes to rest, or when the particle is momentarily at rest. So the when is the time, the where is the distance. So and when the particle comes to rest, then that means v is equal to 0. So that means when v is equal to 0, what are you going to get? the distance and the time. So we equate the whole of this to 0. The whole of the velocity to 0. What are you getting, please? We are looking for the when.
Sir.
Yes, what are you getting?
Say thank you.
He said
2 and 1.
2 and 1. So the time is 2 seconds. The when is 2 seconds and 1 second, right? 1 second. And they are saying that where. So once we know the 2 times, then we can check for the where. The where is the distance. And so when t is equal to 2, the distance is equal to this. This is the distance we're given. So when the time is 2 seconds, what will be the distance? So S1 will be equal to it. When 2 is distant, when 2 is equal to when t is equal to 2 seconds, what will be the distance? Let's put it in this. Then we'll do that one for when t is equal to 1 second. What will be the distance? When t is equal to 1 second, what will be the distance, or what is the where? So we equate it to this thing. We are finding for s. So when t is 2, what are you getting? Use your calculator. Time is going.
7.
7 meters. And do when t is 1, what are you getting? That'll be 8 meters.
Yes.
So we're done for the second question. Then the third question says that we should find for the acceleration. Acceleration. What will we do? Acceleration. When t is equal to 2. Acceleration. What should we do? What are you going to get? So we differentiate this one to again. The acceleration is dividing the t, and this is v. So when you differentiate this again, what are you getting? That will be 12t.
12t minus 18.
12t minus 18. Good. And they are saying that when the time is t, so when t is equal to 2. Sorry, when t is equal to 2, what are you getting, please? Are you getting acceleration to be equal to 6. So this will be per meter square. That is it. Now the d, that'll be the final part. The d, what are you getting? The d says we should find for, if the acceleration is 8.4, then the question says we should find for, please someone should read the last question for me.
We should find velocity when the acceleration is 8.4 meters per second.
Okay, so if acceleration is equal to 8.4 meters per second, meters per second squared, then we can equate it to the acceleration equation we had here and come and get t. And when we come and get t, then we come and put it into the velocity equation and find for velocity. Do you agree?
Yes, sir.
So that would be 8.4 is equal to 12t is equal to 12t minus 18. What is t? T will be equal to, what is t, please? T will be equal to, is it 2.2? 2.2 seconds. Then the question is you should find for the velocity. So now you already have the equation of the velocity. This is the equation of the velocity. So when t is equal to 2.2, we just factor this one and come and get the velocity. Then we are done with the question. So put 2.2 into the velocity equation, dx dt. So when t is equal to 2.2, what will be the velocity? Velocity will be equal to what are you getting? You get a certain 1.44. 1.44 meters per second. How many of us don't understand? How many of us don't understand? It's just like transferring physics into maths. That is all. Well, this is the last topic we are doing under differentiation. The next week we do integration. And we are done. I'm done teaching it. What was the last? How many of us don't understand? We all understand here. Okay. I'll put a question on the platform. Do it and send it to me. Private message, please. Everyone should do it and send it to me. Private message. We are done for the day. I'll put it on YouTube. Those of us who don't listen, go over again. We are done with differentiation. We are left with integration.